Hello and thank you for viewing my video. My name is Brian and in this video, I will be going over a basic spanning tree protocol configuration. Topics covered in this video are: per VLAN spanning tree, BPDU or bridge protocol data units, route bridge selection and bridge priority. For ease of the demonstration, I will be using Cisco's Packet Tracer program, which can be found for free on cisco.com. Let's start. What is spanning tree protocol? And why is it used? Spanning tree protocol, STP, is used to prevent loops in a network topology. When the network contains multiple paths between two devices, data can flow along the different paths, which can create loops sometimes called broadcast storms. During a broadcast storm, broadcast packets are forwarded out all ports, which in turn gets looped back into itself via the multiple paths. This causes the network to get saturated with the broadcast and it can no longer process new data and we end up with a network failure. STP stops the loops. How do we end up with multiple paths anyways? The answer is most of the time we do it on purpose, to build redundancy. The main goal of network engineering is to keep the network operational at all times. Speed, latency, or any other goals do not matter if the network is down. So we purposely use backup paths in the network in case one path fails, the devices aren't stranded and data can still flow over the backup link. Let's create our topology with a router, 3 switches and 2 computers. After powering it up the first time, this switch has PVST spanning tree on by default. We can see the spanning tree mode PVST command is already in the configuration. The command spanning tree extends system. It is basically used to make sure the switches never come up with the exact same bridge ID. Now I'll start configuring. Hostname. Not necessary, but I like to turn off domain lookup unless needed. Let's create VLAN 2. Now we will configure all the ports connected to the other switches as trunk ports. Let's check the trunks with the show interface trunk command. Check on VLAN 2 with the show VLAN command. I'll change the name that Packet Tracer labels it as for easier viewing. On to the next switch. We'll do the same configuration as switch 1, but we'll add the PC port to VLAN 2. Switch 3, same as switch 2. Now I'll configure the IP addresses on the computers. Next I'll configure the router. Hostname. I'll no shut the parent interface connected to the switch. Now I'll give it a sub interface and turn on trunking with the encapsulation.1q VLAN 2 command. And assign it the gateway IP address I added to the computers. I'll change the Packet Tracer label as well. assigning the computers the default gateway and their addresses. Let's test some connectivity. We can ping the gateway and the other PC on the network. Our network is up and working, but we have a physical loop. Why is there no storm? How is it working? Well, that's because PVST was configured by default, remember? If we run the show spanning tree command, we can see STP is working for both VLANs. Here we see the root ID priority. One of the switches needs to become the root switch. This switch will have working links to the other switches. The lowest bridge ID becomes the root switch. The other switches will have one link connected to root and forwarding, and the second link will be set to blocking and effectively become a backup link. Here we see VLAN 1 has FA0/2 in blocking and FA0/1 forwarding and in the root port role. We can tell this is not the root switch because both ports are not forwarding. VLAN 2 shows the same thing but also shows our computer port in spanning tree. By default, all ports participate in spanning tree unless we tell it otherwise. We can view the spanning tree instances individually by adding the VLAN number to the end of the show spanning tree command. When we check spanning tree on switch 1, we see all 3 ports in forwarding, so this must be the root switch. It also shows here under each instance that this bridge is the root. Like I said before, we can view per instance, and we can see on VLAN 2 this is the root switch for each VLAN. PVST works by assigning a separate bridge ID, BID, to each switch for each VLAN. The switch with the lowest bid becomes the root bridge for that VLAN, and each switch determines the best path to the root bridge for each VLAN. How do the switches know about the other switch's bridge ID? BPDUs are messages sent between switches in a network to communicate information about the network topology and determine the root bridge of the network. The root bridge is the switch that serves as the central point of the network, and all other switches determine the best path to the root bridge. The bridge ID contains a priority value, the MAC address of the sending switch, and an optional extended system ID. When the switch is first connected to the network, it sends BPDUs out of all of its ports to discover other switches in the network. If the switch receives a BPDU from another switch with a lower bridge ID, it will stop sending its own BPDUs out of that port, and instead use the received BPDU to determine the root bridge. Now if the root bridge fails or a new switch is added to the network with a lower bridge ID, BPDUs are sent out to all switches in the network to update their information and determine the new root bridge. There are 2 types of BPDUs switches send. First is the configuration BPDU, sent by root bridges to provide information to all switches. The second one is the TCN BPDU, or topology change notification, sent by bridges towards the root bridge to notify changes in the topology, such as port up or port down. As we saw, by default STP comes right up and automatically determines its root bridge and starts to work. But we want more control. We want to be able to designate which switch is root for each VLAN, and that's what PVST allows us to do. In the real world, we would want to try and balance the traffic on the links, and perhaps we send half of the VLAN's traffic down one path and the other half down over the other path. We can do that by setting the bridge priority in a way that we are determining the root. Let's change the root to switch 3 for VLAN 2 with the spanning tree VLAN 2 priority 0 command. Now the switch is root. And all ports are forwarding. For now, that is all. Let's recap. Per VLAN, spanning tree is one variation of the spanning tree protocol. We use spanning tree to prevent network loops for switch topologies with redundant links. BPDUs are what the switches use to communicate with each other and determine which paths will be used and which will be blocked to prevent traffic storms. A root bridge is selected by having the lowest bit or bridge ID. Bridge IDs are made up of the bridge priority MAC address and an optional extended system ID. We can change the bridge priority for each VLAN instance in spanning tree so we can determine path selection and balance traffic over redundant links. We will go over the other types of STP in future videos as well as more details about STP. But for now, know that STP is a vital tool for network administrators because it helps ensure the reliability and stability of a network. Oh, and always, document. Thanks again for watching and Please give a like and subscribe so you will be notified when more videos are uploaded.